In the previous video, we had a module to check pins 6 and 7, and send out the state of these pins. Here you can see the messages in the serial monitors of both units. The changes are the pins getting grounded and ungrounded. Today we are going to focus on the Can Led2 sketch from the GitHub repository. As this builds on from the Can Led sketch, I will focus on the changes from that sketch, which I think need to be explained. So far you will have spent 27 minutes watching the tutorials, if you have watched the full series of videos. I have also added an email address to the video descriptions if you wish to contact me concerning anything I have shown so far. The first changes to the code is to add the second global variable for the LED on pin 6. One important thing I did not mention in the previous sketch was the need to use a current limiting resistor to protect the LED from burning out. I would suggest using something like 220 ohms resistor in series going to the ground pin. Also, if you plan to drive anything else, you need to take care, as the Arduino GPIO pins can handle very small currents only. Check the data sheets. Back into the code, the next thing to do is set up the LED on pin 6 as an output. That is the only change needed in the void setup function. There are no changes to the void loop function as this is not needed in this sketch. The void receive ISR function, which can be seen on the left, has been totally changed. And on an interrupt it calls another function called receive message. Again, this function will not return any value, but just works through the various lines of code. The first change you will see is the changes to the variable types used for the len and rx buffer. From Unit 8, T to byte type variable, both versions are designed to handle messages received through the CAN bus, but they have different approaches to message interpretation and LED control. The new version focuses on extracting information from a formatted message, while version 1 looks for specific commands in the message payload. The final line of the function is to call the function named processMessage. This function takes 3 parameters, rxid, an unsigned long representing the message ID, rxbuff, a pointer to a byte array representing the message data, and len, a byte representing the length of the message data. Variable declaration, int pin, declares an integer variable to store the pin information extracted from the message. Int state, declares an integer variable to store the state information extracted from the message. Scanf function, scanf, char, rxbuff, %d, pin, state, uses the scanf function to parse the message data, rxbuff, as a string. The format specifier, %d, indicates that 2 integer values separated by a colon are expected. The extracted values are stored in the pin and state variables. If an else statements, the function checks the value of pin to determine which LED to control. If pin equals 6, digital write, LED_pin_6, state. If the message starts with 6, it uses the state value for setting the LED, so if it is 1, it sets the LED to be on, if 0 it sets it to off, else if pin equals 7, digital write, LED_pin_7, state. This does the same if the message pin 7 and its value is either 0 or 1. In the next video we will look at a producer-consumer module.